Hello and welcome to the Further Maths videos for OCR Pure Core. This is Sequence and Series 1 Summing Series, and this is video 1.5, the method of differences. So the method of differences involves expressing the terms of a sum in such a way that the parts of the sum can be cancelled in a regular pattern. As we go through the examples, you'll see how easy this becomes, but it's really important that you set your answers out correctly. When we express the terms as a difference, this often requires the use of an algebraic identity, and these often involve algebraic products, fractions, or factorial expressions. The identities aren't ones that you need to memorize, but you may be asked to show that an identity is true before using it. So here's an example of a question. And the first stage is working out how your sum can be expressed as a difference of two or more terms. So that's something with a subtraction in it. In this particular example, the first thing that we're asked to do is to show that 1 over r minus 1 over r plus 1 is identically equal to 1 over r times r plus 1. So the first thing that we're going to do is we're going to rewrite these as fractions over a common denominator. So we're going to have r plus 1 over r plus 1 minus r over r plus 1. And we can see from here things are going to cancel out nicely. Remember, if you're asked to show something, make sure you show enough steps rather than just jumping straight to the answer. We can see what the answer is going to be. So now that we know that we can rewrite this expression here as differences, we can now look at doing this sum using the method of differences. So we're asked to find the sum from r equals 1 to n of 1 over r times r plus 1. Now we know, because we've just done it, that we can write this as the sum from r equals 1 to n of 1 over r minus 1 over r plus 1. And now what we're going to do is we're going to write out the first 3 terms and the last 3 terms of this sequence. And I'm going to write them out in a very particular way so that you can see what's going to happen. What I'm going to do is I'm going to substitute in 1, write that on one line, and then when I substitute in 2, I'm going to write that on a separate line. So when I substitute in 1, I get 1 minus 1 over 2, so minus a half. And remember, it's a sum, so then I'm going to add on whatever I get when I substitute in 2. So that is a half minus a third. And then again, I'm going to now substitute in 3. So I've got a third minus a quarter. Now this will continue. And then I find it easiest to write the last term, so when we're substituting in n, so 1 over n minus 1 over n plus 1, and then work our way backwards. So the term before would have been 1 over n minus 1 minus 1 over n, and the term before that 1 over n minus 2 minus 1 over n minus 1. Now when we look at the method of differences, you'll see why I've written it like this. It's important to do at least 3 rows because often the pattern can not be seen until then. In this one, you could have seen it after 2. And it's important that we do the beginning and the end. So you can see that this term here is going to cancel with this one. This term here is going to cancel with this one. This term here would cancel with whichever one's here. Now if we go down to the bottom, we will see that 1 over n will cancel with this, 1 over n minus 1 will cancel with this one will cancel with the term that was here. And what we're actually going to be left with is this 1 at the beginning, which isn't cancelling out, minus 1 over n plus 1. Now generally try and simplify that into a single term if we can. So that is going to be n over n plus 1. So from what looked like it could initially be quite complicated, we end up with this nice simple expression. Okay, so we're going to have a look at another example here. First of all, we need to simplify this expression. So what I'm going to do is I'm going to take out a common factor of r plus 1 and r plus 2. So if I take out the common factor of r plus 1 and r plus 2, then I'm left with r plus 3 from this term and minus r from this second term. So if I simplify those, I'm going to get 3 r plus 1, r plus 2. And now that we've found that, we're hence going to find this sum from r equals 1 to n of r plus 1 times r plus 2 times r plus 1. Now if you look at these, we can see that what we've got here, this difference, gives us 3 times r plus 1 times r plus 2. So we're going to need to take that into account when we do our calculation. So you can see that this can be written as a third of what we get when we use the method of differences, because here we have this extra 3. So now we are going to substitute in. Now I often find it easier if you've got a fraction outside to deal with that afterwards and to just do the sum from r equals 1 to n of r plus 3, r plus 2, r plus 1 minus r plus 2, r plus 1 times r. So if we work these out, if we substitute in 1, we're going to get 24 minus 6 plus 60 minus 24. You can already see they're starting to match up. Plus 120 minus 60. Now sometimes it won't be in the first 2 lines, and you need to know that if you're using the method of differences, this should happen eventually and keep going till you see something. So our last term is going to be n plus 3, n plus 2, n plus 1 minus n plus 2, n plus 1 times n. The term before that, n plus 2, n plus 1n minus n plus 1, n minus 1, and the term before that, n plus 1, n minus 1 minus n minus 1, n minus 2. So now when we look at what cancels, we can see we've got 24 and 24, 60 and 60. So we know that 120 will cancel. So this term here at the end cancels with this term here cancels with this term. And what you're actually left with is minus 6 plus n plus 3, n plus 2, n plus 1. But remember, all I've done here is find the sum from 1 to n. I need a third of this to be my actual solution. So I've got a third of minus 6 plus n plus 3, n plus 2, n plus 1. And now I'm going to try and simplify this, rearrange it so that it looks a little bit nicer as an answer. So I've just multiplied out here. And if you follow this through, I suggest you pause it, have a look at the algebra as you go through, and make sure that it all makes sense to you. And here is our final answer. The sum from 1 to n of r plus 1 times r plus 2 is n over 3 times n squared plus 6n plus 11. Okay, so other examples that we use might contain factorials. So if we remember that 5 factorial means 5 times 4 times 3 times 2 times 1, so n factorial is n times n minus 1 times n minus 2 times 2 times 1. We can also then look at what the relationship is between 6 factorial and 5 factorial. So if we have 6 factorial, that's just the same as 6 times 5 factorial. So if we have n plus 1 factorial, that's just the same as n plus 1 times n factorial. And in terms of simplifying, that can actually help us out. So if we've got r plus 1 factorial minus r factorial, that is the same as r plus 1 times r factorial minus r factorial. And now we can take out a common factor, r factorial times by r plus 1 minus 1. So that's going to give us r factorial times r as required. And now I'm going to leave this example here for you to do, to have a go at then finding what the sum of this series is using the method of differences. This is in exercise 1 on integral, so you can check your solution on there. Okay, that's the end of this video and the last video in the series, sequence and series 1, summing series.